In this video, we'll discuss matrices and arrays in MATLAB. An array is an ordered collection of data items that is identified by a common name. In MATLAB, all variables, irrespective of their data type, they are regarded as multi-dimensional arrays. That means even if you have a variable that is holding a scalar value, that is also actually treated by MATLAB as a 1 cross 1 array. If you have an array that has only one dimension, then we call that as a vector.
If we have an array with two dimensions, that's rows and columns, we call that array as a matrix.
Let's see how we can define matrices in MATLAB. Let's create a matrix A with following elements: A equal to, the elements can either be separated by spaces like this, 1, 2, 3, 4 and 5. This is one way, or we can as well use this notation: A equal to 1 comma 2 comma 3 comma 4 comma 5. Both of them are equivalent. If we want that, we should create, for example, a 2 cross 2 matrix. Then we can do it like that. For example, B is our matrix with following elements. In the first row, for example, we have 1 and 2, and when we have to move to the second row, then we can use a semicolon, and then we can have the elements for the second row, suppose 3 and 4. Can use comma as well as space as delimiter between elements. So this is a 2 cross 2 matrix. We can as well define a matrix by listing each row on a separate line. For example, if you have a matrix C equivalent to suppose -1, 2, 2, then a semicolon for the first row, and for the second row it can be like this: 1, 1, 1, the second row, and second row ends by using the semicolon. Then we have the third row. Suppose these are the elements on the third row. Next we go to another row. This is the fourth row. For example, it's 6, 7 and 8 on the last row. Here is how we end it. So here we have the matrix. Create the same matrix, similar matrix, without using semicolon. For example, we create a matrix D equivalent to 0.9, 9.9, whatever. We zoom in. This is first, 2.1, 2.8. This is the first row. Hit enter. Now we are writing the second row. Although we have not used semicolon, but when we hit the enter key, means we are now writing elements for the second row. 5.3, 2.9, example 7.3. Again going to the next row, that's the third row, 2.9, 12.5, 5.8, and this is the last row. So we'll close this square brackets and we have the matrix. We can change the values in a matrix by indexing into the matrix, or by indexing into the array, because matrices are also a type of array. If we want to modify this value 9.9 to 10.4, we'll write like this. D is the name of matrix at which position we want to make a change. 1 comma 1 equal to 10.4, for example, equal to. So it has been modified. Rest of the matrix is same. Colon operator is very powerful operator in MATLAB. We can use colon operator for defining matrices in a very compact form. For example, let's create a matrix D equal to 1 to 8 or 1 to 10. So our matrix D got populated with numbers from 1 to 10 with just this one command. We are not required to type in each of the elements. Similarly, we can use step size. Here we are not using any step size with colon. If we don't use any step size, then the default increment is 1. We can use a step size, for example, like this: D equal to 1 to 1, then step size, for example, this time we'll keep it as 2 to 10. What MATLAB will do is that it will generate numbers from 1 to 10, and at each time the number will be generated by incrementing the previous number by this step size, that's 2. Let's see, hit the enter key. Here we have. Let's use colon operator to create a multi-dimension, for example, 2-dimensional matrix. Let's name that matrix as H equal to 1 to 10. Let's suppose 1 to step size 2 up to 10. And this is first row. The second row will be 2 to 10. So first row will actually comprise of the odd numbers between 1 and 10, and the second row even numbers between 1 and 10. Let's see. So here we have. Now this colon operator can as well be used to extract a specific column from the matrix M. For example, if we write like X equal to H of H is the name of this matrix, then we use directly colon comma 1, then it will extract the column 1 from this H matrix and assign it to another matrix X. Let's see here. By using this colon, we have extracted the column 1 from this H matrix and assigned that column to X matrix. For example, we want to extract now the fourth column. We can issue the command 4. If we want to extract the first row, then first row. So we got the first row and so on. MATLAB provides a number of functions to create and manipulate matrices. For example, if we want to create a 3x3 zero matrix whose all elements are zeros, we can invoke the function zeros, and the argument, for example 3, will be a 3x3 matrix. And we can as well have different dimensions for rows and columns. For example, 3 rows and 2 columns will generate. Okay, one more function is there, ones. If we want to generate a unit matrix, one matrix whose all elements are ones, we can just apply it the argument. It will want to ones, we can invoke the function once and supply the argument as we have done with zeros, we can have different number of rows and columns with ones function as well. Ones, for example, 2 comma 3, so 2 rows and 3 columns, all ones. Can extract the diagonal of a two-dimensional matrix as well. For example, we have a matrix A equal to 1 2 3 3 4 and 5 and 1 2 and 3. Then if we use the function diagonal diag, then passing the argument the input matrix, we got the diagonals is 1 4 and 3. You can as well flip the matrix into its mirror image. Flip this matrix A to its mirror image. So the function is flip LR, then the matrix A. So this matrix has been flipped, as you can see. This time it has been flipped right to left. We can flip it vertically as well. Example, by using the function flip UD, passing in the argument as the matrix. So here we see this time it has been